everyone, welcome back to the shop. In today's video, we're going to be talking about how to design an off-grid power system. Now I have this power system opened up, so there's no wires or cables or anything like that. I'm really trying to get the layout correct before I go ahead and start cutting the 80/20. I'm making a lot of decisions where it won't be good to go back on them because I'll either be wasting 80/20 or cutting unnecessary cable links. So I'm just going to walk you through the way that I do this, and hopefully it helps you out with putting together your system. This is not necessarily a complicated system, the one that I'm putting in this van. However, you may want to do something more simple or more complex, but essentially the design principles pretty much work out the same way. The first thing would be your size of your system. We're going to talk about amp hours and stuff like that in a second, but as far as the size, let's talk about the footprint of your power system. Now, in the vans that I build, I try to make the power system as compact as possible with, at the same time, trying to dial into what the needs are of the customer. So for example, in Thomas's van, which is Marine 1, we needed a system that could charge his Paragolfer, which was a electric wheelchair. It could charge that, it could run induction stove, it could run a microwave, those type of items, but we were limited with the footprint. So in his van, we could only fit 4 lithium iron phosphate batteries. Because we could only do 4, what we did is we used more solar as a supplemental charging solution for the power. And we only used 30 amps off of the engine. And we'll get to that in a second. So since we only could do 4 batteries in the tight space that we were working with, we really had to figure out how we were going to orientate the batteries. So the first thing was we found out where we could put the power system, which was actually on the passenger side over here, over the wheel well. And once we found out where we were going to put it, the orientation of the batteries was important. So you can see here I have 1, 2, 3, 4, 5 100 amp hour batteries, and then I have another 6 one right here, but it's rotated. Typically you want them all to be in the same direction because you need the cable, so the power cable that you're going to put your lugs on, to be the same distance from each terminal. That's really important. So what we'll have to do is we'll have to measure this battery to this battery, and then that'll be our standard going to the rest of these batteries. It's going to waste a little bit of wire, but it's the correct way to do that. Like I said, in Thomas's van, we couldn't go width-wise with the batteries. We had to go long ways. And by doing that, we could only fit 400 amp hours of batteries in there because we needed room for we're using Red Arc for Thomas's. This one we're going to use this Renogy system. So the Renogy 1, we'll talk about that too. But we used the Red Arc system, so where the box was mounted, where the Link's distributor was mounted, it was a very tight space to work with. So what we did is I did a mock-up just like I'm doing right now, and that allowed me to kind of play with things as far as moving them around. So I'm not strictly designing this on the bench. I want to design it exactly where it is. So the first thing I do, and I talk about this on a live stream on the channel, so you can go back and check out that video. But during that live stream, I talk about designing the 80/20 to hold the power system. And I do that first just to get the footprint. And if I can just get the footprint, then I build that on the table, I can make sure that when I put it back in the van like I have now, I can start to fill it up with some components. I don't want to build it too far out so I'm not wasting material, because if you see the tape right here, I'm making a lot of changes to this. So I don't want to be too aggressive. So essentially just make the outer frame, like the cage, and then I do it to where I can actually put some batteries in here. And this unit, I'm building out of 80/20 because there's a lot of weight in here. The heaviest item is this inverter charger. It's about 65 pounds. It's a 3,000 watt inverter charger. This is not the one we're going to be using. We're going to be using the new Renogy Rego. It has an internal Bluetooth connection that's actually going to be part of the new Renogy One system. This is an off-grid solution. You can actually use this in a van as well as if you have an off-grid cabin or something like that. And what this is going to do is all of our devices are going to connect via Bluetooth through this Bluetooth module and through this communication hub. So we'll have the inverter charger. Each one of these batteries over here, these are the Renogy lithium iron phosphate smart batteries. They all have a network port. So it's technically an RS-485 plug, but it's like Ethernet. And each one of these batteries will plug in and they can all go into this communication hub. And then we also have our two Renogy DC to DC MPPT 50 amp charge controllers. So they're integrated. So you get the DC to DC charging from the front of the van via the alternator, and then you have an input for your solar. So we'll connect all the batteries, the charge controllers, as well as the inverter to this communication hub, and then we'll just have one output via the BT2 connector, and with this we'll be able to communicate to the Renogy One controller. We'll be able to see all the parameters of our system. So that's kind of in a nutshell what we're working with here. Now back to the weight of the inverter charger. It's extremely heavy. So you may be wondering, well, you're probably just going to sit it on the ground. We can't do that because we need airspace at the bottom and the top, and we need room for the cables. So this inverter charger is actually going to be hovering about 2 inches off the bottom of the van. So we're going to cut a notch, and that'll give us our airspace for ventilation. And then we'll orient the inverter charger so that it's pulling the cool air from the bottom and exhausting the heat through the top. And then we actually have a vent plate that goes on top to really give it a nice professional look. And that'll be the inverter charger. So since it's going to be hovering, that's a lot of weight. We need this frame, this 80/20 frame, to hold that heavy weight safely. And then as we move from left to right, what we're going to do is we're going to start to space out all of our items in here that we need to use for one, communication, and for our charging capabilities. Now as we're orientating everything, you'll notice down here on the right hand side we have a Webasto parking heater. And so this heater, we've designed this frame to allow all of our batteries to be housed, the inverter charger, and then our controllers down here. We want to make sure that there's enough room so that we have enough airspace so that we're not roasting our batteries. So we get enough airspace and ventilation over there, and we do. Same thing with the sides of the panel. We want to make sure that this is wide enough so that it's not direct contact to the heater, but it's enough to where it's not too much for our batteries, because we actually want the panel that's going to go here to assist in holding the batteries in place. We will have a strap over the top to ratchet these actually down. So that's how they're all going to be held. But we had to first design around that. We had to design around the weight of the inverter charger. And then next we have the weight of all of these batteries. So right now all these batteries are only being held by 2 runs of this 80/20 extruded aluminum. So right here where the blue tape is, we're going to have a post come up, and that'll allow us so that it doesn't actually sag and deflect. So once we have all those kind of items checked off our list, we can start to see how much room we have left for our charge controllers, or MPPT, solar controllers, as well as our Links distributor. I love the Links distributor because this box is a very simple way to have a very organized power system. So you're going to need, in any off-grid system, you're going to need a way to handle the higher, or to fuse the higher current loads. So this box, it has 4 terminal locations, or fuse locations. And what we're going to do is our incoming power from our batteries are going to come into these 2 terminals here. And then they're going to come in and they're going to go over a fuse. So it's a mega fuse. So once they go over the mega fuse, they're going to come out here at the bottom, and that is going to go towards our high current devices. So our inverter charger, there'll be a port for our air conditioner. So we're going to use an Dometic RTX 2000. And then we'll have 2 additional ports here, and that's actually going to be the input power from our DC to DC charge controllers. So we'll be connecting those fused to the system. So we'll not only be charging the system via this box, but we're also going to be fusing our big current loads. We'll have one part of this system that will be coming off, and it'll be going to an external fuse box that'll be located where the kitchen galley is, and that is going to do all of our low current devices. So our LED lights, our USB ports, things like that, our water pump, that'll all be powered via that. The nice thing about the Red Arc system was that was built into the distribution box itself, so the Manager 30 that we use in Thomas's van. However, this one, it's not necessary for us to control all the devices via a wireless means. For example, Thomas needed to make sure that if he was out of the van, he could still control everything from his phone, so he wasn't hopping in and out of the van. Or if he hopped in the driver's seat and was driving, he didn't have to park, get back in the van, and then turn off any switches. So say if he forgot the water pump was on or stuff like that, he could do that. However, I will be using the Renogy One controller for 3 wireless connections. So these wireless connections can be controlled via the app. They're wired directly into the Renogy One controller right here. And you can see these are off and on switches. And we can do 3 circuits. So we'll have, for example, the interior lights. We'll have an open one. So this one can be, maybe we want to break up the interior lights into the overhead lights. And the second one can be a lower set of LED lights. And then the final one I'm going to do as a water pump. And I'm doing that because if you're in or out of the van, the water pump is something that if you forget to turn it off, you want to be able to do it easily. So let's just say you're driving and you forgot to turn it off. Instead of pulling off, you can just turn it off via your phone. And the way that I'm going to wire these up is these will normally be, the circuit's going to be on. And you can wirelessly turn it off, but it's going to be defaulted to on. Because each one of these is going to have a physical switch. So the lights will have a physical switch upon entry, so that when you enter the van, you can turn it on. You don't have to access the app. You don't have to access this panel. It's just more convenient. Same thing with if you wanted to use the water pump for washing some dishes or washing something down. You don't have to go to this panel to turn it on. You can do that from the app. So with this, you're going to have those 3 switches that you can choose from, and it just makes it more convenient to control stuff in your van. Now with that being said, we've covered the structure. So this is what the basis of holding everything. We found out stuff that can't move, so our inverter charger is going to be mounted there. We have our Webasto heater. We have our battery locations. That's pretty much fixed. Now we want to figure out where our components, our smaller components are going to go, such as these charge controllers and the distributor. That's our next step. Now, why is it important to figure out how these go in? Can't you just put them in and where they go and kind of check it off the list? The challenge here is each one of these devices has a different way that your cables exit from the unit. I have this in my personal van. I've used this for a long time. Each of these is a 50 amp controller. However, the way that Renogy did it is, you can see here we have nice terminals. They're labeled really well. We've got all of our connections and communication. However, the port at the very bottom, you can see is very small. So you have these openings down here at the bottom and openings down here at the top. So we're going to be using a 6-gauge wire for this. So I have one positive here, but I have the communication cable coming out, and it's a very tight squeeze. So not only mounting this can be a concern, but go ahead and take some sample wire or extra wire and just kind of put it in the hole, and then find out how much room you need for this to actually bend out of the way. So the challenge that we have is the bottom here is 80/20. And so depending on our mounting location, this is how far. We don't want to pinch this wire, because if we need to do maintenance on this wire in the future, it's important not to make it to where if you needed to unbolt it, run a new wire, you could do that. So we don't want to squish this wire, but at the same time, we need to consider this heat sink on the back. This does, for a 50 amp one, this one gets pretty toasty. So we want to make sure we have enough airspace from the bottom so that we can let the air pass through the back and up through the top. So you got to think of all these things before you kind of lock everything into place. So on the bottom here, what I'm going to do is I'm going to see how much room I got from the bottom 80/20 to this top bar. Now I've set, my top is fixed because I have the Adventure Wagon L track that this whole cage is going to bolt into. So this will become a structure of the van. So my height is fixed, my width is fixed, and my depth is already fixed because of the batteries. So that's what you got to make sure you sketch out on a notepad, your fixed measurements. From there, we'll get a measurement from this bottom section, and what I'm going to do is I'm going to mount this DC to DC charge controller halfway, and so that'll give me my maximum space for my wire to both enter the top and the bottom. Because this system, since we're using the Renogy 1 controller, typically you could not use a communication device with this charge controller. You just kind of let it work on its own. It has a button on the side where you can input if you're doing like AGM or lithium battery. So you don't have to connect it to an app or Bluetooth. However, we are. So we're going to have all these network cables on these batteries. We're going to have network cables on these two controllers. So we're going to be using the top and bottom port. By doing it halfway, we're going to be able to maximize our room to pull this wire. So once we get these two boxes fixed and we can access the wires for both charging and communication, we'll check that off the list. The next thing is we start to run out of room pretty quickly. So this is why it's important to start mocking this up, because our plan is we're going to take this whole entire box out of this. We're going to put it on the bench where I have all my, I've taken a marker and I've gone through and marked everywhere that I need to add 80/20 for supports for these boxes, support for this battery that is in a different orientation. So once I do that, I can take it out and I know where I need to cut and add my supports to. That way it's just easier to work on the bench after I've figured this out instead of going back and forth into the van. But running out of space makes things easier because you know that there's only so much room you have to work with. So after we have these located, we're happy with that. The next part is we're going to take our links distributor, and you'll see why I had to change the orientation of this battery. So the links distributor, it cannot go in this way because there's not enough depth. It can go vertical, but this is where the visual aesthetics come into play. If you guys saw in Thomas's van, I had an acrylic piece of plexiglass, and I had our Odyssey Custom Vans logo. So I want to do that for this one as well, really show off some of the interior electronics. And we're going to have a LED light in here that's going to glow and really show off just a really nice, neat wiring job that we're going to do here in a second. All right, so this box, we want to show off some of our Victron components. So we rotated this battery like this, and then this, since we're not using this side, we can move it all the way down as far as we need to. So what we're going to do is we're going to mount this box almost to where it's touching the top here. And that'll be our location for this box. So what we can do is take a piece of 80/20 and we can just put it in here and just sit it on top of there. And then that way we can, we'll get it centered, and then we'll mark, hopefully it doesn't fall off while I'm filming here, but we can mark where this is. Obviously this will be pushed back, but it's just for visual purposes right now. Now, one thing I learned from the tight space in Thomas's van is how quickly this, I think this is 2/0 wire, 2/0 cable, no, 4/0, is how quickly this 4/0 cable takes up space. And the reason I'm going over this is everything is starting to get really tight right now. So we're going to be using this 4/0 to connect our batteries. We're going to use it to connect batteries to the Link's distributor, as well as connecting to our inverter charger. So imagine you're going to have two coming from the batteries. You're going to have two going into the inverter charger, and then you're going to have two going into, well, essentially the cable that's coming from the AC unit, the air conditioning unit, that's going to be a very thick cable as well. So this space is going to get full really quick. We got all our communication wires, we got our 4/0 cables. So what's nice about this channel right here is this is where everything's going to be very neatly, this is going to be our cable run. So this is where everything's going to be very neatly cable managed and going to all of our devices. So if you think about it, each one of these boxes, it needs a positive wire, it needs a negative wire, it needs a network cable. It's going to have a solar input. But you can already see we have about 10 cables that are coming out of these boxes. So all that is going to have to be managed very well because we want to show off how we're connecting everything. And we're going to do that on purpose. We could just plug everything up and have a mess of wires and then hide it, but we want to show it off. So we're going to do specific runs, and right here is where everything is going to be connected. Before the distributor, we're actually going to do one more component. It's not necessary for the Renogy One system because inside each one of these batteries, the system's able to, via Bluetooth, show the charge level of the battery, so how much capacity it has. But since I'm testing this Renogy One system in this van, we're going to be installing a Victron Smart Shunt, and that way we can monitor that via Bluetooth, and we're actually going to have a gauge in the back of this power system, and that way we can monitor it as well. So that's going to be housed right here, and that's really all the space that we have. Last but not least, we're going to have our final wires coming in and out of the box. So in the front of the van, we're going to have two 6-gauge wires. So these wires are going to supply the alternator power from the van into this power system to charge it via the engine. The alternator on this Ford Transit is a 250 amp alternator. According to the forums, we need at least 70 amps of reserved power for the van itself. We can safely use 100 amps to supply these chargers. So that we're going to use 2 of these. So those will be coming into the van. For our grounding location, on the back of Ford Transits, there's a grounding panel or strip It's on the passenger side as well as the driver's side. So we'll tap into that with our negative wires. We'll have our Dometic RTX 2000 air conditioner on top. I think that system uses 4-gauge wire that comes with the kit, so that'll come down the inside of the van, come around, and it'll come into our power system. And last but not least, we'll have our wires coming out from the system. So that will be our Renogy 1 controller. So we'll have our communication cable going to that. And then we'll also be running another 6-gauge wire underneath the van to our kind of remote fuse panel. They'll be powering all of our low current devices. So that's a little overview of this system. The next step obviously is to start crimping and cutting and crimping all of our wires for the system, and then we will finish up the 80/20, get everything mounted. We'll probably do a time lapse of that. Let's talk about the batteries. So we skipped over why we have 600 amp hours of batteries. So one, it's as much as we can fit in this space, so maximizing as much batteries as you can is very good. But at the same time, it is enough for us to run our Dometic RTX unit on the top. So a 3000 watt inverter typically needs about 300 amp hours of batteries. So 300 amp hours would be fine for this system, but we doubled it so that we have some usability in our air conditioning unit. So to make a vehicle truly off-grid, we don't want to just check a box up and say, we can run an AC unit for an hour and a half. No, we don't want to do that. We want to run our AC unit for 6 to 12 hours at a time, because if you're in a van and you're sleeping in the bed, you want it on during the night. And running it for an hour or two is not going to cut it. There's a lot of videos I've seen to where someone is advertising that the off-grid system can run the AC unit, but you really need to be careful and ask how long specifically can the batteries run that system. So we're going to be doing a test, and I'll show you guys once we put the AC system on how long 600 amp hours can run that system on Eco. Eco seems to be the way to run those units because it's a pretty powerful unit. But we'll talk about that. Yeah, so that is kind of the off-grid system in a nutshell. This is the system we'll be using in this van. If you guys have any questions on this system, put that in the comments below. I'm happy to put that in a future video. As always, check out our DIY van build cheat sheet. This cheat sheet is essentially an Excel document, and it's all the components that I've used to build vans over the last 3 years that I bought specifically through Amazon. So these Renogy controllers, this power cable right here, Windy Nation, you'll see the links in the Excel sheet. So a lot of these components that are in here, or pretty much all of them, are going to be, if they're not already added to the sheet, it's a living document. So we add it over time, and it's always growing. We've got over 250 curated items that are on that list, and essentially all you have to do is put your name and email, sign up for the list. It's completely free. It's going to come straight to your inbox, and it's going to allow you to just easily get these components. The components are vetted by me, so you're not having to worry about buying stuff and then it not being the right thing for you. That is going to allow you to save time and money. The time from finding the components, and the money is for you buying stuff that you don't need and wasting money. You can just go on this list, check out the link, specifically buy something that I'm using on the power system. It doesn't have power. It has all kinds of components. It's got parking heaters on there. The most important thing on the list is the tools. So all the tools that I use to crimp, cut, and heat shrink these cables, as well as stuff that I use to attach the 80/20. So all the components, all the corner brackets, the button head cap screws, lock washers, that's on the list, as well as hole saws for the power disconnects, it's all in that list. So it's all in that list. It's in one spot. It's completely free. So check out the DIY van build cheat sheet. Click on the link in the description below. That's going to take you right over there. Just put your name and email address. It'll come directly to your inbox, and I really think it's going to help you out, save time and money when you're doing your DIY build. All right, that's it for this video. I hope to see you guys in the next video, and we'll talk to you real soon.